All right, ladies and gentlemen, welcome to your video lesson for 2.2, creating and solving equations. In this lesson are going to be various examples of word problems that we are going to break down into algebraic equations that we can then use to solve real-world problems. So without any further ado, I'm just going to adjust the view of this a little bit more, make it a little bit bigger. All right, so a little bit of a warm-up from last class. Identify the terms and coefficients of the expression. Remember that terms are separated by addition symbols, right? So I can separate here. I have to change this to add the opposite, so I will do that. I want to get my smaller pen here, so adding the opposite. Still drawing with that pink, but adding the opposite, so that's -3. And now if I draw my line down that and down here, I've now separated my terms and I have the signs correct. So my terms are 5x, 2y, -3z, and 2. And remember, coefficients, we can actually look at the terms we've listed to come up with coefficients. In order to have a coefficient, we have to have a variable. So we have variables here, here, and here, which means our coefficients are the numbers out in front of those variables, and those are 5, 2, and -3. Okay. Again, another warm-up problem. Write an algebraic expression to find the model, the situations. We have the price of a dinner plus an 18% tip. So the price of the dinner, remember last lesson we just called P, and then plus, we're now just going to add, and now 18% has to be converted to a decimal, and we have to think now 18% of what, and that's going to be of, which means multiply the original price. We're adding an additional 18% of the original price, okay? And again, as we showed last class, this can be simplified to this is 1p here. This can be simplified to 1.18p. And now, if you know what the price is, say the price is $20, take 20 times 1.18, and that will give you the price of your dinner plus the tip. All right, so the price of a hat, for example, 2b here, price of a hat, we're going to call that P, with a discount of 25%. Now, it doesn't say plus or minus. We have to interpret this word discount. So we're going to be paying less, which means we're going to subtract from that price, right? And how much are we going to subtract? 25%, which is, as a decimal, 0.25. And then 25% of, which means multiply, of what? Of this original price. So there we go. Multiply times that original P. And again, we can simplify this. This is a 1, and then 1 minus 0.25 is 0.75p. So another way to look at like discount is like, sometimes you'll see like percent off or marked down. However the language is, essentially we're subtracting a percentage. We're always subtracting from 100% of the price. So if it's 20% discount, well, if it's 100% that I'm going to pay minus the 20%, you have to think what's left. Oh, 80%. Well, that would be 0.8 times the original price to give you what you need there. Okay. All right, moving right along. Today, again, like I said, creating and solving equations from word problems. So we're going to be modeling real-world problems in the entire lesson. All right, so a little bit of a teaser here. Mr. Bratz is going to build a rectangular patio. He wants to put a fence around it, but he has 200 feet of fencing he has to use. So he's got a limited amount of fencing that he purchased. The patio's length must be 13 feet more than twice the width. What is the length of the width of the patio? Now, at the end of this lesson, we are going to answer this question, okay? But one of the things we have to understand about this is what is the perimeter of any figure, right? In this case, it's a rectangle. Well, the perimeter is just adding up all of its side lengths, right? So if I have a length here and a width, and then the opposite sides are the same. So this would also be the width, this would also be the length. And so the formula for perimeter is kind of two different ways. It could be the L plus the L plus the W plus the W. However, I can simplify that and combine some like terms. So I can really simplify it. The perimeter, specifically for a rectangle, is 2 lengths, right? 2 times the length plus 2 widths, 2 times the width. We're going to get back to that later, and we will answer this question at the end of the video. But that's just kind of where we're headed today. All right. So a little bit of a practice translating sentences into equations. So let's go through these. So sum means addition, right? The sum of a number, the sum of 6 and a number, so a number I'm going to translate to any variable, right, that's equal to, right, is equal to 11. All right, so what are we doing? We're taking 6 and a number, and we're putting it together in a sum. That's addition. So 6 plus a number is then equal to 11. So there's my equation. Notice that when I add, though, we know this about addition, right? The order does not make a difference. And I mention that because now down here I have a difference, which means subtraction, and the order does matter. This one says the difference between a number and 12 is 2. The difference between a number and 12 is 2. Now, when you hear that subtraction is going to be done and it's the word difference, whatever comes next has to happen in the exact order that it's stated, because in subtraction order matters. So the difference between, all right, now I know I got subtraction, right? So what comes first? A number, boom, n, x, whatever, and 12, there we go, means equal to. Okay, that's the equation for that one. So just remember to, when you see difference, that the subtraction has to go in order. 3 times a number increased by 7. So this would be 3 times a number, which is 3n, right? Increased by 7, so plus 7 equals negative 14. I think that one's pretty straightforward. 3 times a number, bam, increased by 7, that's adding 7 equals negative 14 given to us. All right, now 1/6 a number minus 2 is 4. So 1/6 a number, that's implying multiplication. So 1/6 times n or x minus 2, boom, equals 4. All right. And then this last one here, excuse me, gotta extend my page. 5 times, now it's not saying 5 times a number, it's saying 5 times a difference. When you see that, right, when you see that, you have to think to yourself, I'm multiplying times an operation that's already happening. So what's already happening? The difference of a number and 10. So I'm going to have that difference of a number and 10. Remember, we talked before, the difference number has to come, or the order has to happen exactly as it's stated. So a number and 10, so n minus 10. And then 5 times that difference, that indicates, with parentheses around it, indicates that the difference has to happen first, and then I am multiplying that by 5. And then is equals 20. All right, so a little bit of a warm-up there for translating language. So now let's get into example number 6 in your notes. All right, Aaron and Michelle are bowling. Michelle's score is twice the difference of Aaron's score and 10. The sum of their scores is 409. We're going to find each of their scores. Now that sounds on its face super potentially confusing, right? So let's just break this down. So here, I'm just going to break it down. We're going to define some variables here. Whenever we're doing an algebraic real world problem, we have to know what we're talking about. So I've defined my variables. I'm saying M is going to be what Michelle's score is, okay? And E is going to be representing what Aaron's score is. So we got M and E. Aaron and Michelle are bowling. Michelle's score is, so I'm just going to kind of take notes on that. Michelle's score is, so if Michelle's score is M, that means I got M equals, right? Is what? Twice the difference. Okay, so now I'm multiplying 2 times some difference. Then it says Aaron's score and 10. Well, Aaron's score is E, and 10 is what we're talking about there. Okay, so that is how we broke that down, right? So one more time, Michelle's score is, so that's how we got the M, equals is the is part, is what? Twice the difference, right? So that told me I was multiplying 2 times some quantity. It's going to be a difference, right? I did the difference, and the difference is Aaron's score and 10, boom, E minus 10, and then it's 2 times that. Okay, we know nothing about Aaron's score, right? We're not told anything about it. So for Aaron's score, we're just going to say E is equal to E. We don't know anything about it. But M is equal to that 2 times E minus 10. And that's all we're given, right? So now we're told to find the sum of their scores is 409. Now this is going to be important for writing the equation. It says the sum of their scores is 409. What that means is that if I take Michelle's score, which is M, plus Aaron's score, which is E, that's going to be equal to 409. Now check it out. I know that M is equal to this 2E minus 10. So this is where we're going to get our equation from. We're going to take the 2E minus 10, substitute that in for M, add E, and then that's going to be equal to 409. So just one more time, the sum of their scores, right? So I'm going to take M and E and add them up. That's going to be equal to 409. I know that M is equal to this expression here, and I'm just substituting that in. And that's how I come up with this expression here. All right. So the sum of their scores, again, this represents the M portion, right? And then E obviously is that. So now I just solve this for E, okay? So I'm going to distribute. I have 2E plus, I'm going to add the opposite here. So plus negative 20 plus E is equal to that 409. All right. So I have some like terms combined here. I now have 3E minus 20 is equal to 409. And now I just have a two-step equation, 409 rather. So now I got a two-step equation, so I'm going to add 20 to both sides. I have 3E is now equal to 429. And now I'm going to divide by 3. And when I do that, E is then equal to 143. And now I have Aaron's score, okay? So that's half of the problem, right? So now what I have to do, now that I know Aaron's score, I know Aaron's score is equal to 143. So E equals 143. Now I got to substitute that back in here, right? Now I have to substitute it back in and say, all right, well, Michelle's score is going to be equal to 2 times that 143 minus 10. So 2 times 133. My picture here, and that'll give me 266. So together, Michelle's score was 266, Aaron's score was 143, and that'll give us our 409. All right, next example. A rectangular garden is fenced in on all sides, and I'm sorry, a rectangular garden is fenced in on all sides with 256 feet of fencing, okay? The garden is 8 feet longer than it is wide. Find the length and width of the garden. So the rectangle is already kind of filled in for you here, right? The rectangle garden is 8 feet longer than it is wide. That's why we have the width labeled here. This is also W, right? And then the length is, the length of the garden is 8 feet longer than it is wide. So that's where we get the W plus 8 for the length, right? So that's why it's just labeled here. This would also be W plus 8 on the other side. Now, our perimeter formula, remember we broke this down to be P is equal to 2 times L plus 2 times W. And so now I can just start substituting what I know. So the perimeter is 256 feet. And then that's equal to 2 times, and then the length is that W plus 8. Plus, and then the width is just W, so 2 times W, which we already have, is there. Now I got an equation very much like I had before. So now I'm going to go ahead and distribute this. That's 256 is equal to 2W plus 16 plus 2W. I have some like terms that combine, so I got 256 is equal to 4W plus 16. I would subtract 16 from both sides. That gives me 240 is equal to 4W. And now I divide by 4. 4, I think I wrote a W. 4. Let's make that better. And now when I divide, I get W is equal to 60. And so that's the width, right? So the width is 60 feet. And now I also have to find the length. So just like the last problem, if I know one answer, I can substitute it in to find the other. So if the length is equal to W plus 8, then I can say length is then equal to 60 plus 8, because I know the width is 60. And so the length is 68 feet. And those are my dimensions. All right, so if you need to see that again, stop, rewind, go back. I'm pressing forward. All right, Claire just bought enough fencing to enclose either a rectangular garden or a triangular garden as shown. The two gardens have the same perimeter. I'm sorry, the two gardens have the same perimeter. How many feet of fencing did she buy? So they both have the same perimeter, which means this is equal to that, right? And so what we're going to do is set these things equal to each other, and we're going to solve for x and then plug x back in to figure out how much fencing she bought, okay? So this expression here, right, I really have a 3x minus 3 and an x minus 3 over there because it's a rectangle, so I don't want to forget it, right? And this one's already here. So I have to take all of this and set it equal to all of that. So what that looks like is, and there's two of these, right? So I'll say 2, and then I'll just do the width here. So 2 times x minus 3 plus 2 times 3x minus 3, right? Now that has to be equal to all of this. What I notice is that these two things are the same. So then I'm going to say 2 and then 2x minus 1 plus 2x, okay? That's my start. So I'm going to start distributing to here, not there, and then here. And so what I'll end up with is 2x plus negative 6 plus 6x plus negative 6 equals, and then here, right, 4x minus 2 plus 2x. Now I got a bunch of like terms combined. This is going to give me 8x minus 12 is equal to, and I've combined terms here, 6x minus 2, okay? I want to subtract the 6x from both sides. That'll give me 2x minus 12 is equal to negative 2. I'm going to add 12 to both sides, and I'll get 2x is equal to 10. Divide by 2, I get x is equal to 5. Now all I have to do is substitute this into any one of these, right? And if they have the same perimeter, I'll be able to figure out, now that I know that x is 5, what that perimeter is. So the easiest one to me is this triangle, right? So I'm going to substitute it into this expression. So 2 times 2, and then 5 goes in for x, plus 2 times 5. Oh, forgot the plus 1 there. Let me do that again. All right, 2 times 2, and then the 5 is going in for x, plus 1, right? That's going in here. It's negative 1, plus 2 times 5. All right. So if I distribute, here I get, well, I can't distribute, I got to simplify, right? So I have 2 times that 10 minus 1 plus 2 times 5. I'm going to extend the page here a little bit. 10 minus 1 is 9. So I have 2 times 9, and then 2 times 5 is 10. 2 times 9 is 18 plus 10, and I get 28 feet. So each of these figures is 28 feet long. So what did we do? We took the perimeter equation for this and set it equal to the perimeter equation for that because we were told the perimeters were equal. So I set them equal to each other. That allowed us to solve for x, and then we substituted x back in to find out how many feet of fencing there was. All right. We got 2 more problems here. A veterinarian is changing the diets of 2 animals, Simba and Cuddles. Simba currently consumes 1,200 calories per day. That number will increase by 100 calories each day. Cuddles currently consumes 3,230 calories per day, and that number will decrease by 190 each day. The pattern will continue until both animals are consuming the same number of calories. So the goal here is to figure out how many calories, how long it's going to take for them to consume the same amount of calories. That's what it's asking. And how many days will that be? How many calories will each animal be consuming? We are going to answer just one of these calories, okay? How many days will that take? And then we can talk about how we would use it to solve the rest of the problem. First thing we got to do is write an expression for Cuddles. right? Cuddles, I guess we can do Simba first because that's mentioned first. So Simba's expression, Simba currently consumes 1,200 calories per day, 1,200, and they are going to be increasing, so adding 100 calories per day. So X equals days here. All right, so Cuddles currently consumes 3,230 calories per day, but we're decreasing 190 per day. Now, I want to know when these two animals are consuming the same number of calories. So what that means, if I want S to eventually be equal to C, that means I'm going to take the expression for S and set it equal to the expression for C. So this equation ends up looking like that 3,230 minus 190x. Now that's equal to the 1,200 plus 100x. And now x represents the number of days. If I solve this equation, the answer will be, how many days will that be? How many days until they are eating the same? Now I got variables on both sides. I'll draw my line through the equation. I'm going to add that 190x to both sides. That is the best first step. Now I got 3,230 is equal to 1,200 plus now 290x. And now I have a two-step equation, right? What's happening to x? I'm multiplying by 290, and I'm adding to 1,200. So I'm going to first subtract 1,200. Bring this up a little bit. So when I subtract 1,200, I'm left with 2,030. That's going to be equal to the 290x. Now all I got to do is divide by 290. And what I get is 7 is equal to x. So to answer the question, it will take 7 days until they have the same diet. So again, what did we do there? We wrote an expression for Simba. We wrote an expression for Cuddles. And then we were told we wanted to figure out when they are going to be eating the same amount of calories. So in order for them to be the same, we had to set them equal to each other. Once we did that, we were able to solve for x and then figure out how many days it would take for that to happen. If I want to figure out how many calories that would be, I would just substitute that into any one of the expressions. And in fact, it's actually really easy. Like if I use Simba's equation down here, that's 1,200 plus 7 times 100, or 100 times 7. So that's 700. It's 1,200, right? Which would give us 1,900 calories for Simba, for both of them. So each one will have 1,900 calories. All right, last problem here, and this one is the one we started with. So let's knock it out. So Mr. Bratz is going to be building a rectangular patio. He wants to put a fence around it, but only has 200 feet of fencing to use. So that's going to be related to our perimeter, right? The perimeter of his fence is going to be 200 feet. The patio's length must be 13 more than twice the width. Length L must be equals 13 more than plus twice the width. Now I just kind of broke into that, but I think it felt natural, right? That's the equation for L. What must the length and width be? Now we don't know anything about the width. So in this patio, I'm just going to label these sides W because I don't know anything about them. But I know from that sentence before, the patio's length must be, so L equals 13 more than. That means I'm taking something and adding 13 to it. Because the order doesn't matter, I can do that in the beginning. 13 more than what? Twice the width. Well, what's the width? It's W. All right, so then 2W. And this side is the same, so this is also going to be 13 plus 2W. Right? So my job is to now find the length and the width. So now that I got an expression for each dimension, what I need to do is go ahead and solve this. So perimeter is going to be equal to 200. That's going to be equal to 2 times my length, and my length I established as 13 plus 2W plus 2 times the width, which is just W. Okay, now I got to distribute here. Boom, boom. So I got 200 is equal to 26 plus 4W plus another 2W. All right, I got some like terms to combine. So now I have 200 is equal to 26 plus 6W. All right, now solving this, I'll end up with W. I'm going to then, what's happening to W? I'm multiplying by 6, adding 26, so I will subtract 26. That will give me 174, and that is going to be equal now to 6W. The last thing I do is divide by 6. So then I'll have W is going to be equal to 29. And now that I know that W is equal to 29 feet, that's this dimension, right? I can now substitute that in to find the length. The length is equal to that 13 plus 2W. If I know that W is 29, then length is equal to 13 plus 2 times that 29. So 13 plus 2 times 29, 2 times 29 is 58. And if I add 13 to that, I get 71, not 17, 71 feet. All right, so each of these problems is very unique. The idea is being able to go ahead and break everything down into an equation, all right? So problems in your independent practice are going to be similar to the ones that you just saw in this video. Do the best you can at writing an equation and then solving your equation, okay? Don't forget to do your independent practice. I hope you guys have a great day. Peace. I gotta find the window for quitting this.